Happy Polar Vortex Day, everyone. A short video on nuclear energy. I wanted to share with everyone over some of the key concepts related to nuclear energy that we would have covered during today's lecture time. The learning objectives for today are fairly simple. We want to accomplish these two things. Describe how nuclear energy is used to generate electricity. What you'll see is its mechanism for producing electricity is very similar to some of the other sources that we've seen already and some of the ones that we'll see in the future. We also want to discuss the advantages and the disadvantages of nuclear fuels to generate electricity. Nuclear energy is a very controversial way of producing electricity, and so we'll explore a little bit of that as well. There are two types of nuclear energy, and I wanted to very briefly discuss each of the two types just in case you hear, you understand what the distinction between the two is. It's nuclear fusion and nuclear fission. Nuclear fusion is the type of nuclear reaction that actually takes place in our sun. It's a reaction when a lighter nuclei are forced together to produce heavier nuclei. This is an amazing phenomena. It produces a huge amount of energy. It's the way stars and like I mentioned, our sun produces the energy that makes all of the heat and light that radiates out of the sun towards our planet and out throughout the universe. Fusion is an amazing way to produce energy. It's potentially an unlimited source of energy if we were able to actually do it. So at this moment, we don't have the technology in place, both in terms of just the basic science required to do this type of chemical reaction, but we also don't have the engineering solutions in place in order to make this reaction take place and capitalize on what fusion could deliver us. It's something that many scientists across the world are working on, and engineers, but at this moment it's been elusive, and it may never be a reality that we can accomplish just because of some of the challenges that are related. Nuclear fission, on the other hand, is a type of energy generation that we have been able to accomplish, but it's still relatively new. And the way that we produce this energy, it comes from using a nuclear fuel source, which is usually a very heavy element on the periodic table, typically uranium-235. The 235 stands for the atomic number of uranium, and what we're going to do is strike that heavy element with a neutron, and it will split it into two or more parts. And when that splitting takes place, it releases an enormous amount of energy in the form of heat. What can we do with that heat? Well, we can do a lot of things. And one of the ways that we use that heat is to boil water. When we boil the water, it produces steam, and the steam can be used to turn a turbine. This is very similar to the way that it's done in coal and other fossil fuel sources, using heat to boil water to turn a turbine. This is a really great graphic. When you think of what nuclear fission looks like, this is the kind of image, live action image that I want you to have in your mind. So the energy is released when a neutron strikes these large atoms. So when one comes down and it splits it into multiple parts, and the part of this animation that I love is it's showing balls, these little ping pong balls shooting all over this chamber. It's the same with nuclear fission in that once this heavy neutron comes into the chamber, it starts off a chain reaction, and particles are flying all over the place and bombarding one another and releasing heat. And this is sort of what it looks like if we could actually see it with our own eyes, which of course we can't. I'm going to walk through how exactly nuclear fission creates electricity, and so we'll use this graphic in the upper right, this moving animation, to kind of walk through the four basic parts. The slide will get fairly busy, but we want to at least identify, well, what are the main steps related to producing electricity from nuclear fission. The first step is splitting the atoms. So we have these uranium atoms that are inside of this reaction core, and we're going to shoot neutrons at them and set off a chain reaction. The uranium is usually in the core in these pellets that are coated by ceramic, And because uranium is an unstable element, once we split it, it becomes a slightly different, more stable element, but heat and radiation are the byproducts, and the heat is what we're after. The heat is what we want to actually use in this process. Absorption is one of the key parts that we'll focus on, and there's going to be a couple component parts inside the reaction that we want to look at. One of them is the control rod. So control rods are used to absorb these free-floating neurons that are released during the fission process. If you think about that previous animation that we were looking at, particles were flying all over the place and bombarding one another. We need some way to absorb those floating neurons as part of this process, and that is done by the control rods. The next thing we do is release a metalloid element, boron, and along with water to help absorb as well. And this helps contain the radiation. The worst case scenario for this chain reaction is if we can no longer contain the radiation or the reaction or keep it cool and safe. So this is all related to allowing the chain reaction that we want to take place without it taking place in a crazy and frantic manner that can actually cause harm. So the absorption, this is the part of the process that's mostly related to the safety and functionality of this, this process. The next is where all the money is, the heat. So we're using the heat that's released from this chain reaction to heat water. And the water serves two purposes. One thing it does is it keeps the reactor from becoming overheated, which is not something we want, but it also is used to make steam, which we can use to turn turbines. So turning turbines is something that we've seen again with coal. It's one of the most common ways to produce electricity, and so a turbine is a key component part inside of a nuclear reactor that we're using to produce electricity. The last thing is this water and piping, and if you look at this animation, you can see water moving all over through here. The continuous flow of water around the reactant helps keep it cool. Keeping it cool is really critical, again, as part of the safety, and it allows movement of energy to go in and out of the chamber. And so the primary reason that we're using this cool water in the tank is to help keep the reactor cool, and as the hot water heats up, we want to remove that from the reaction chamber and cool it down and then recharge it. So using that cycle, if we just kept the same water in there, it would get too hot. So we're constantly replenishing the water that's inside the chamber with new cool water to cool the reactor down and then produce new steam. The two items that we're really interested in inside of this in terms of a definition, one is the fuel rod. So it's this cylindrical tube that has the nuclear fuel inside the nuclear reactor. So this is where those uranium elements, the atoms inside of these ceramic coated pellets, are actually found. And then the second item that we care a lot about is the cylindrical device. It's called the control rod, and its job, if you remember from before, is to help absorb the excess neutrons. And this is actually functional to slow or potentially stop the reaction from taking place. So the control rod, very critical for the safety of this energy production, this energy generation process. Nuclear, like I mentioned before, it's a very controversial form of producing energy, and part of its controversy comes from its great potential, but some of the disadvantages. So let's look at that, but first let's focus on the advantages. This has an extraordinary power for producing energy. One small little factoid that I really like here is that per atom, nuclear energy is over 1 million times more energy than from comparable fossil fuel. So when we think about the energy potential inside of a nuclear power option, it's really large. One of the other key things that a lot of environmentalists like is it doesn't produce air pollution like burning of fossil fuels. It helps improve energy security because you don't have to import. It can be centralized, it can be large scale, and once they're built, they have relatively low operating costs. So from an economic standpoint, there are a lot of people who are supportive of them. From an environmental standpoint, there are a lot of supporters because it doesn't produce any air pollution, and just the power potential is really large. It's extraordinary, actually. Disadvantages, though. Part of the reason people are so skittish is because there have been a number of nuclear accidents, and they've been, accident is the wrong word, they've been catastrophes. 3 Mile Island in Pennsylvania, one here in the United States. One of the most recent was the nuclear disaster in Fukushima in Japan after a tsunami damaged the site and released a bunch of radiation, and so it was the convergence of a natural disaster and this nuclear power plant together. And so all of these disasters have really, they've been high profile, they've been in the news. Dying of radiation is probably one of the worst fates any human could face, and because of that, and also we have nuclear bombs from World War II that people are familiar with, so there's been a lot of apprehension around nuclear as a power option because we know it can cause great harm to people and the environment. Part of the environmental cost associated with nuclear is it produces this nuclear waste as a byproduct, and it's really difficult to dispose of. We actually have no good answers for how we want to dispose of it. And then we have concerns about if we're producing nuclear energy, the science behind releasing atoms because it can make such extraordinary energy. One of the interests for a lot of governments or regimes is that it could be used to make nuclear bombs. And so for this reason, there are a lot of opponents that prefer for it not to be out in the marketplace globally, for it not to be commonplace, for it to be somewhat very regulated and controlled to help suppress some of these concerns around nuclear material being misused for purposes especially related to making weapons of mass destruction. The radioactive waste piece from the disadvantage, this one hits close to home, and it's kind of a cheeky way of saying we have radioactive waste in our backyard right here in St. Louis. So let's look at what radioactive waste is and think about why this is such a disadvantage of this energy source. After nuclear fuel can no longer be used to make enough heat, so as the quality of the energy of the atoms is degraded over time, we can no longer use it to boil water and produce energy, but it still continues to emit a high level of radioactivity. And it's what comes out of the fuel rods, and so we have to find somewhere to put that radioactive material, and it takes an extraordinarily long time in order to decay. So these low-level radioactive wastes, they can be found on all kinds of items, especially people who are exposed to it, and so we need to have some way of dealing with that because of its ability to cause harm to living systems. The uranium mines, where we actually get the uranium to begin with, also has tailings and residue that's left over from the mining process. So we have radioactive waste that's getting out because of the energy production. We have radioactive waste that's just getting on items associated with producing energy and having a nuclear power plant. And then we have all of the nuclear residue that we have to deal with that's related to mining the uranium. So 3 categories of radioactive waste, and we have to have some way of dealing with all 3 of those. In each case, great care has to be used to handle it because exposure to even low-level radioactive material can cause great damage to cells and really disrupt and denature living tissues and cause harm very quickly. Here's a short video from the Energy 101. I thought it would be nice just to put it on here, and you can watch this video as many times as you want, but it reviews some of the information that we've talked about and gives a little bit more just so that you can hopefully understand, well, what is nuclear energy, how does it produce energy, and what are some of the advantages and disadvantages associated with it.